So we had a bit of a discussion on how effectively we move air, and the engineering is absolutely brilliant on how effective we can move air and how many cubic feet per minute, and it's at some wonderful controls. But having said that, Penn State did a really great study under Dr. Kowalski, and they said that if you release tuberculosis at the bottom of a 10-story building, within 8 hours, that very effective system had a 33% infection rate at the 10th floor. So that's how effective we can move disease or things that we really don't want, but we need something like a Bioshield, something that will make the difference. Now, in particular here in this slide, what we're looking at, even though it's a cartoon, don't make complete light of it, but it's very accurate when you come in and meet the staff, S-T-A-P-H, you're not just meeting people, but you're also meeting, MRSA and strep and pneumonia and all those wonderful things that are walking the hallways literally in hospitals. And they're not just on surfaces, but they will be a hard surface, but also on your clothing. They will be actually on your skin. Will move freely through the air system, and that's what's contributing to disease. Now, the facts are now that 25% of the patients admitted will acquire a hospital infection, and of those 1.7 million infections, there will be approximately 100,000 people will pass. So it really brings out that when you've got a concentration, yes, you will get a higher concentration of those who will be infected. And when they are infected, it could result in loss of limb or their life. So is there some way that we can clean up those environments? And you'll see in the test later on that we have tested for MRSA, for staph, for Pseudomonas, which is what your lungs would fill up with fluid, for influenza, C-difficile, and all these ones that are typical in a hospital. And shortly, we will have our test back for CRE, which is an emerging disease that is worldwide now, and we have no defense for it. So for these ones that we've spoken about, there are protocols, but what about the new and emerging diseases that there are no protocols? So again, to be able to donate a functional immune system to a building is, now you're sort of catching on how important that would be. We talked about hospitals, and this is really a revolutionary slide. It has been ignored. It was done in 1964 by the environmental lab at Penn State. And so when you got environmental engineering, they should know their stuff. And 82% of all illness comes through our eyes and our nose. So what's the purpose of handing this to people for decades when there's no way of getting biologicals away from our nose and our eyes? We have no means of doing that. We will try and do that through filtration, but filtration can't get all the bugs. And I've got another series here that maybe we can address that. It's not on the slides, but I do have a PowerPoint that shows where filtration stops, and here's all the stuff that leaks through. Think of trying to stop sand with a tennis racket. Even though HEPA is the best filtration that we've got, there is stuff that will just rattle right through that, just like I said, sand through a tennis racket. So if our eyes are open when we're walking and we're breathing, that's the route of transmission will be through those areas, and very little through our mouth. So where do we congregate? Well, we're going to be there at the dentist's office. We're going to be at the daycare dropping the children off. So you may notice that whenever the children are daycare, you're sick until they get a break, because they're touching everything and putting things in other kids' mouths, and they come home, they want to hug and kiss you, and there you go. So you're always in a droopy, weaky sort of state. And wouldn't it be great that we could have this in cruise ships, trains, planes, malls? We saw how the H5N1 vectored from Mexico around the world via aircraft. So they're flying incubators, and they're all breathing the same air. It's being recirculated. So everyone is being inundated with that in their respiratory system, their sinus cavity, and their clothing. So it's inevitable. We have to have barriers to this stuff, or our expanding worldwide population is going to get very ill very quickly. And the word pandemic is kind of frightening, so we need a route of transmission that's going to halt that. So an effective Bioshield is very timely. 100 years ago, we didn't move like we do today. Now we can be virtually anywhere in a few hours. So environments are worse where people get together, and just understanding how this works is really an important thing to deal with. So to walk with a surgical mask or whatever, people always have their eyes open, and the masks are not that effective. Latest EPA study said that our surgical masks are 85 to 100% not effective. Everyone that died in Canada with the SARS epidemic in Toronto was wearing a certified government mask. Got through that. So we need a better form of protection that's not just physical. We need something that works and covers us.